Hello, this is James again, showing you another video for the construction of the Catalyst Mendel. So one of the things I should show you is that there are two motors for each. There's a motor for each bar on the Z-axis, and that was done for simplicity because the belt drive system is actually more costly than the motors are. So these motors I get for $8 to $10 a piece right now. When I have to get regular motors, they'll probably go up to $15 to $20 a piece. But NEMA 17 motors are really cheap. For the parts and everything, just for the belts in the United States, the belts are about $17 to $26. For those of you who wonder what belts are probably most likely to use, it's probably the Toyota timing belts. Those are the ones that have the right spacing, the ones that you would split in half with the splitter that they designed. Plus, I'm not going to be splitting belts. I don't deal with sharp objects. One thing you should know when you make more than one of something, you should never ever deal with sharp objects. To deal with the sharp blades, that just, even if you wear gloves and everything, it's just too dangerous. I'd cut my fingers off. So, there's two motors here. It's just cheaper. What I wanted to do is show you today how to set up your motors and kind of how it works. So let me get this focused down here. What you go ahead and you do, you're going to get two motors. These are the silver motors. They're not as powerful as the other motors. They don't need to be. The Z-axis doesn't go that fast, and so we're not going to use high RPMs. So you're going to get these motors. You're going to want to clip the ends. This tool is not included, by the way. This is just something easy for me so that I don't kill my hands for everything I'm doing. But I'm going to show you some cool stuff here in a second. Okay, so that motor's ready. And I'm also going to provide some cat wire cable for these because some of these are too short, the wire leads, so you're going to want to cat cable them. Excuse me, you're going to want to take the cat wire out of the box that I give you. You're going to want to use some of that wire to make these motor wires long enough. I thought I was going to have all long wire, but it's not possible. One second. So for demonstration purposes, I'm going to set two pieces of paper on each of these motors. This motor right here, and then another one on this motor right here. That way you'll be able to see it better in the video. So, a couple things. So, besides the Z-axis motor, any motor, if you want to know what wires go together for step and direction, you just touch the two contacts together. You hear that? That's from the motors being hard to turn. Then it's easy, and it's hard to turn. That means that one section is together. You could also put an ohm meter to it and put it on check continuity, and if you have a short or you have 3 ohms or whatever, then you got the right leads. So what just matters is that the two that are connected and the other two that are connected, one goes in step, one goes direction. No matter how you set it up, you'll get it working, and then you can always adjust it in software, which one's step and which one's direction, and you can also adjust the pins on the tool and on the CNC to adjust step and direction. So I'm sorry, not step and direction. Step and direction is by the CNC card. Um, the windings, it doesn't matter which order they're in or which direction, you can always change step and direction on the controller card. So the thing is, with Z, you need to make sure that you have your motor wired up a certain way so that they'll spin the same direction. So the easiest way I do is I take the same color wires, and I'm going to go ahead and just twist them together for now. Sorry. So I take the two that when I short out, excuse me, make it hard for the motor to turn. And then what I do is I hook them up like you would in series. And what I do is I take, see, I have the yellow and red wire because those are the two that are together. And then what I do is I take the other motor and I wire the red to the yellow. And then I wire the yellow to red. And then I have the two other wires that when I short them together, make the motor hard to turn. And so I wire those in a series. So you don't put the same colors together, you put the opposite together. So blue to orange in this case. Yep. Okay, just looking at my time in my video. Blue to orange, and then orange to blue. Get these twisted together. And just to be sure, they are wired the same. What you do, you turn this motor, and the other motor should turn the same direction from the current produced from the first motor. And as long as it turns in the same direction, then you know it's wired correctly. So then it doesn't matter which one you do, you undo one red and yellow, and that is now your new connection for those two wires. And then you undo one red and orange wire in this case, and that's your other set. And as long as they spin the same direction, you got it correctly. So these are the wires you use. And the other thing you can do is to know that you got the right two wires is if it's hard to turn, when you put those two wires together, then you got the right wires. And the other two, if you touch them and it's hard to turn, then you know you got the right wires. And if you wonder, again, you can just connect all the wires up and notice that the other motor spins with this one. And then you can wire it up to electronics.